Hi everyone, now we are going to discuss about another one clamping circuit which contain the Zener diode and the normal diode. And here we are going to apply the plus or minus 20 volt across the input supply. There was a capacitor C1 connected in series with the voltage V1. Here voltage drop across the D1 will be 0.7 volt, and similarly the voltage drop across the diode D2 Zener diode will be 5 volt. And here we are going to find out the maximum and minimum voltage at the output. In the clamping circuit, RC time constant of the circuit will be much larger than the time period of input signal. Let us calculate the RC time constant. RC time constant equal to 10 microfarad into 100 kilo ohm, which is equal to 0.1 second. And similarly, time period of input signal will be 200 microsecond. So we can conclude that the RC time constant of the circuit is much larger than the time period of input signal. Let us verify what happened in the positive half cycle. During the positive half cycle, the diode D1 and D2 will conduct, so that the current flowing in this direction. During the positive half cycle, the voltage drop across the D1 will be 0.7 volt, and similarly voltage drop across the D2 will be 5 volt. So that voltage drop across the C1 will be equal to Vc is equal to 20 volt minus V out, which is equal to 20 volt minus 5.7 volt. Okay, and which is equal to Vc is equal to 14.3 volt. So that during the positive half cycle, the capacitor charge up to 14.3 volt, and similarly voltage across the V out will be 5.7 volt. Let us verify what will happen in negative half cycle. During the negative half cycle, the voltage across the capacitor will be 14.3 volt. So that we will consider voltage across the R1 will be V1. And if you apply the KVL rule across this loop, voltage V1 equal to minus 20 volt minus 14.3 volt, and which is equal to minus 34.3 volt. At the same time, the same voltage, the minus 34.3, will appears across the D1 and D2. So that during the negative half cycle, the D1 and D2 will not conduct. Due to this, in the negative half cycle, the output voltage will be 34.3 volt. So that we can conclude that V out in the negative half cycle will be minus 34.3 volt. Let us simulate the circuit. See, here we are going to apply plus or minus 20 volt at the input. Let us verify the output. During the positive half cycle, the output voltage will be 5.7 volt. Similarly, during the negative half cycle, the output voltage V out will be 34.3 volt. Hope you are able to understand how to calculate the RC time constant, and how to consider the RC time constant and the time period of input signal, and how to calculate the maximum and minimum voltage in the clamping circuit. Thank you for the watching.